Have you ever wondered what energy really is? Not just the buzzword, but the quiet thread running through everything that moves, shines, or changes. From the warmth of sunlight on your hand to the pull that keeps the planets in their paths, energy is the universe's currency. It's exchanged, stored, spent, and never truly lost. Every heartbeat, every storm, every star is a transaction in that grand account. We live in a constant flow of it, yet rarely stop to ask what it means or where it begins. If you enjoy slowing down with questions like that, a simple like or subscribe helps others join the same path of curiosity. Settle back and let's explore what it means to call energy the language of nature itself. If energy is the true currency of the universe, what does that really mean? The word feels familiar, yet vague. Something you might recall from a classroom or see printed on a power bill. But energy is not just a line item or an abstract idea. It is the quiet foundation of everything that moves, grows, or changes. Every sound, every breath, every star that burns in the distance is part of the same flow. It is not a cold concept, not something distant or detached. Energy is the unseen current that connects the slow turning of galaxies with the beating of your own heart. It moves through every atom, every living thing, every corner of space. It has no beginning that we can touch and no end that we can see. It is simply the way the universe keeps its balance and keeps time with itself. To picture energy as a kind of currency helps bring it closer to everyday life. Money moves from person to person, changes form, is stored, borrowed, traded, or spent. It powers entire systems without ever truly being destroyed. Replace every coin and note with light, heat, motion, or the bonds that hold atoms together, and you have the same principle. Energy is what allows work to happen, what lets things shift, change, and move. From the birth of a star to the flicker of thought in your mind, it is the same story told at different scales. Energy cannot be created out of nothing, and it never really disappears. It only moves, transforming from one form to another in a perfect, endless cycle of exchange. It is wealth that cannot be hoarded, only shared. Once you start to see it that way, the connections appear everywhere. The bread you eat in the morning is sunlight stored in grain. The light from your phone is powered by fuels that once lay hidden in ancient rock. The rhythm of your breathing depends on tiny molecular coins called ATP, adenosine triphosphate, that release just enough power for muscles to contract and cells to live. Every action, from the growth of a forest to the turning of a turbine, is part of this invisible trade. We are all participants in a grand economy that never closes and never stops moving. Before there were theories or equations, people sensed this truth. Energy made itself known through what could be felt and seen. Fire, wind, water, sunlight. Fire was the first teacher. A flicker of flame meant warmth in the cold, protection from the dark, safety from wild animals. It was the difference between surviving and freezing. A small campfire could dry wet clothes, cook raw food, and make tools stronger. It could also vanish into ash if left untended. To early humans, that made fire seem alive, half spirit, half matter. They treated it with respect because it demanded care. If neglected, it punished. If nurtured, it gave life. Without it, nights were longer, colder, and far more dangerous. No wonder early people saw it as a gift from the gods, a piece of the sun brought down to earth. Then came the realization that the real source of all warmth and growth was above them. The sun was the first constant. Long before anyone knew about fusion or photons, people understood that everything good came from that golden light. Crops rose under its gaze. Rivers thawed at its return. The rhythm of life, waking, working, resting, followed its rise and fall. Ancient farmers marked its path with stones and shadows. Temples, pyramids, and monuments aligned with the sun's journey, their designs serving both practical and spiritual aims. When sunlight struck a temple's inner wall at the exact moment of the solstice, it was a sign that the world was still in harmony. The sky had answered back. To the ancients, that meant the universe was listening. Even now, with our knowledge of nuclear reactions and space telescopes, the sense of reverence remains. Every living thing on Earth depends on the energy that streams from our star. The ancient worshippers were not wrong. They simply used the language of their time. Science now gives different words to the same awe. Energy from the sun drives winds and weather, feeds plants, warms oceans, and fuels nearly every chain of life. It is the constant heartbeat of the planet. But humanity's relationship with energy reached beyond the visible sun and fire. People in different parts of the world spoke of subtler forces. The Greeks called it pneuma, the vital breath that animated life. In India, it was prana, the current that flowed through every living creature. In China, it was qi, the balanced energy that maintained harmony between body and cosmos. These ideas came not from measurement, but from observation and intuition. Breath was life, and life meant motion. When breath stopped, motion ended. Something invisible moved through every living thing, and that something seemed to connect all of nature. Even without instruments, people felt that energy was everywhere, running like a hidden river beneath the surface of the world. Across distant cultures, stories grew from this shared sense of connection. In Egypt, the sun god Ra sailed across the sky each day, carrying light through the darkness. In the Americas, the Aztecs believed the universe demanded a continual payment of energy to keep the cosmos alive. In the icy north, myths told of fire and frost clashing to create the first land. Whether through story or ritual, people were reaching toward the same truth. Existence depends on an unseen exchange. Life is not static. It is a flow, and that flow requires respect. Without thermodynamics, they had myth. Without equations, they had balance. And in their own way, they were right. You could say that ancient religion was humanity's first attempt to describe energy. When you lack the words of physics, you build symbols instead. If fire gives warmth, then a fire god must grant blessings. If sunlight feeds the fields, then a sun god must be honored. These ideas followed a logic of gratitude. Too much fire burned, too little froze, too much rain drowned crops, too little starved them. Harmony was everything. Balance kept the world alive. It was, in a sense, a moral version of the first law of thermodynamics. Energy cannot be created or destroyed, only transferred. The ancients did not need to phrase it that way, they lived it. Their buildings reflected the same awareness. Stone circles, pyramids, and temples were built as tools for understanding the heavens. They were physical prayers, frozen geometry, designed to echo the movements of the stars. Watching sunrise pierce the inner chamber of a temple on the solstice must have felt like a conversation between human hands and the universe itself. Observation and worship blurred into one. In that narrow space between curiosity and reverence, humans found meaning. The charm of those early interpretations lies in how much truth they captured without knowing it. They recognized cycles long before science named them. The sun rose and set, seasons turned, the tides came and went, breath flowed in and out, fire burned and died. Even the rhythm of the body followed the rhythm of the world. Without using formulas, they understood that energy moved in patterns, that balance was survival. Too much or too little of anything tipped the scale toward destruction. Harmony, not power, was the key. Over time, energy became another word for life itself. To be strong was to be full of energy. To be weak was to be drained of it. To die was to return it to the earth. Rituals, medicines, and prayers all worked to keep that current flowing smoothly. The words may have changed, but the feeling did not. Even today, we talk about being charged, drained, recharged, or out of steam. These are echoes of ancient beliefs, proof that the same understanding still hums beneath our modern lives. We may speak in scientific terms now, but the idea is as old as humanity. Energy is what makes us alive. Modern science eventually gave us the language to measure and test what earlier people felt. The sun's energy does sustain all life. Breath does carry oxygen, which cells use to release power stored in food. Fire really is controlled combustion, a cousin to the quiet reactions inside our bodies. The old intuitions were not wrong. They were simply unquantified. Energy is sacred because it is essential. Without it, nothing happens. There is no growth, no light, no motion, no thought. The same laws that shape galaxies also power your heartbeat. Looking back, it's easy to smile at the old myths. Gods hurling lightning, spirits guarding the flame, rituals meant to coax the sun to rise. But beneath the stories was a clear attempt to understand something real. They gave energy, faces, and names because they knew it was too important to ignore. It was the unseen force that moved the world forward. In that sense, myth and science are not so different. Both are ways of paying attention. Both seek the patterns that hold reality together. Energy has always been that hidden pattern, whether wrapped in the robes of a sun god or written in the equations of a physicist. It is the warmth of a hearth, the glow of a candle, the pulse inside a living chest. For the ancients, it was divine. For us, it is measurable. Yet the reverence is the same. It remains the invisible wealth that makes existence possible, the single thread that ties the smallest cell to the largest star. We may no longer chant to the dawn or offer incense to the flame, but the recognition remains. It is there each time you pause to feel sunlight on your skin, light a candle in the dark, or draw in a slow breath. The connection continues through every heartbeat, every spark, every wave of warmth that passes from one form to another. Energy moves through us, sustains us, and links us to everything that has ever lived or will live. Long before science named it, humanity already knew it. What changed over time was not our dependence on energy, but our ability to describe it. The same awe that once inspired myth began to take mathematical form. Curiosity replaced ritual, and the language of gods became the language of laws. We discovered that the invisible current we had long worshipped followed precise patterns, rules written into the fabric of reality itself. Energy may seem endless, but the universe keeps strict books. It runs on order, not wishful thinking, and energy must obey those rules. Beneath the burning of stars and the hum of engines, beneath the work of every cell, there are laws that describe how every exchange takes place. Physicists call them the laws of thermodynamics. You can think of them as the terms and conditions of the universe's single currency. The first of these laws is comforting in its simplicity. Energy cannot be created or destroyed. It can only change form. The universe never loses track of its wealth. When energy leaves one place, it appears somewhere else. A log burning in a fire becomes light, heat, and smoke. The food eaten at breakfast turns into movement, warmth, and thought. Even the electricity that once flowed through a bulb is not lost when the bulb burns out. It simply disperses as warmth into the surrounding air. The first law is a promise that the cosmic account is always balanced. Imagine that account as a great ledger stretching across all time. A galaxy spends its nuclear fuel to shine. A planet absorbs some of that light. A tree stores it in its leaves, and a person later eats the fruit. Every transfer is recorded, every transaction balanced. The total energy in existence today is exactly the same as it was billions of years ago, and will remain the same billions of years from now. Forms shift, but the sum endures. The second law brings nuance. It tells us that while energy is never lost, it tends to spread out. Useful, concentrated energy gradually disperses into forms that are less organized and less able to do work. This is the law of entropy. The first law is the rule of balance. The second is the rule of wear. If the universe's account never empties, entropy ensures that its currency becomes harder to spend. Entropy sounds abstract, but it can be understood through simple examples. A cup of hot tea left on a table cools on its own. The warmth moves into the air. A neatly stacked pile of books will topple if disturbed, and no breeze will ever restack them perfectly. The energy still exists, it's just been scattered. The heat from the tea now lives in the room's air. The potential energy of the books is spread among fallen pages and the vibrations of sound. The process is one way. Disorder grows naturally, while order must be maintained through effort. In this way, entropy is the universe's gentle tendency toward evenness, the drift from concentrated wealth to shared simplicity. For stars, this balance defines their lives. They burn bright only as long as they can keep their energy concentrated in their cores. Over time, that fuel spreads outward and the fire dims. Life itself survives by pushing back against entropy, by taking in sunlight, food, or fuel to hold local order against the wider tide of disorder. Every breath you take is a small act of defiance, gathering concentrated energy before it diffuses into warmth again. You must keep eating, not because energy disappears, but because you need to keep reclaiming it before it scatters. Entropy is not an enemy. It is what gives time direction. You can scramble an egg, but never unscramble it. Smoke can rise from a candle, but never gather itself back into solid wax. This difference between forward and backward gives the arrow of time its point. It tells us why the past feels different from the future. Energy remains constant, but its quality drifts toward the uniform, and that steady drift is what allows change to unfold. To see both laws in motion, picture a fireplace on a winter night. The wood holds chemical energy, stored sunlight bound in matter. Strike a match, and the bonds release their wealth as light and heat. The room grows warm, and the air fills with a quiet, orange glow. The first law ensures none of that energy is lost. The second ensures that the heat will eventually spread until it is indistinguishable from the air around it. The ledger is balanced, yet the spending power is gone. Entropy has taken its fee. Physicists sometimes call this the cost of doing business in the universe. Every process pays. Machines lose energy as friction and heat. Stars radiate light that drifts away forever. Bodies release warmth into the night. You never lose the currency, but you can't spend it twice in the same way. The flow only moves one direction, toward dispersal. The result is a universe both full and fading, rich, yet always spending itself. This pattern creates a quiet beauty. The first law offers assurance. Nothing is wasted. The second brings humility. Nothing stays sharp forever. Concentrated energy, like a flame or a heartbeat, will always soften, spread, and blend into the background hum. But that same process gives motion, growth, and time their meaning. Each ordered moment is a temporary island built against the tide, a small miracle that will one day dissolve. Energy is eternal, but form is fleeting. From this viewpoint, every act in nature becomes part of a grand exchange. The laws of thermodynamics are the rules of that marketplace. The first law promises balance. The second defines the cost. Together, they create the story of every system, from a candle's flicker to a galaxy's glow. Nothing escapes the accounting. Every spark, every breeze, every heartbeat is a transaction in the cosmic ledger. To see these principles play out on Earth, look to the sun. Every morning, whether veiled by clouds or blazing in a clear sky, it rises and pours a fortune of energy across the planet. It does this without calculation or limit, sending light across 93 million miles of space as though distance were nothing at all. To Earth, the sun is not merely another star. It is the investor whose generosity funds every process of life. Without that constant deposit, the world would fall silent and still. With it, oceans move, forests grow, and entire civilizations flourish. Sunlight is not just brightness, it is the delivery of pure power. In a single hour, the Earth receives more energy than humanity uses in a whole year. Most of it flows quietly into the natural systems that sustain life. The first to seize this wealth were plants. Through photosynthesis, they learned to turn sunlight into stored energy, transforming weightless photons into sugar. This is perhaps the most important exchange in planetary history. Plants act as nature's bankers, collecting solar deposits and saving them in chemical bonds. The process itself is elegant. Carbon dioxide from the air and water from the soil combine, driven by sunlight, into glucose, the simplest form of stored fuel, while oxygen is released as a byproduct. That oxygen fills the atmosphere. The glucose powers the plant's growth. With this, the first true economy of life began. Every creature since has depended on it. Herbivores draw directly from the plant's savings. Carnivores withdraw second-hand. When they die, decomposers recycle what remains. Every link in the food chain is an exchange in the solar marketplace. A zebra grazing on grass is not only eating it, is making a withdrawal from a green account managed by plants. A lion feeding on the zebra is taking another withdrawal. When the lion falls, fungi and bacteria reclaim what's left, returning matter to the soil, so plants can invest again. This is what we call an ecosystem, a perfect circle of exchange built on sunlight. Waste is never wasted. Even decay becomes resource. The biosphere runs on recycling and efficiency. Each creature, both spender and recipient, in the same vast network. Think of sunlight's journey. It begins in the sun's core as energy released by nuclear fusion. It travels through layers of plasma, crosses the vacuum of space, strikes a leaf, and becomes the sweetness of fruit or the grain of rice in a bowl. The energy moving your body right now can be traced back, photon by photon, to the heart of a star. When you walk, speak, or dream, you are spending sunlight transformed by life. Forests show this economy at its richest. In a rainforest, every layer from the canopy to the soil is a living marketplace where light is exchanged and reused. Tiny insects, bright birds, prowling cats, and unseen microbes all take their share and return it in new forms. The energy flows continuously, creating stability out of constant motion. The same principle shapes the oceans. Near the surface, microscopic plankton capture sunlight, forming the foundation of vast marine food webs. Whales, fish, and coral reefs depend on this hidden scaffolding built from light. Without it, the seas would be silent deserts. With it, they pulse with life. Humans are no different. Agriculture is our method of managing solar income. The wheat in bread, the rice in fields, the vegetables on a plate, all are packages of stored sunlight. Livestock serve as middlemen, consuming plants and passing that energy to us. Early farming was humanity's way of stabilizing the flow, ensuring a reliable harvest of calories. Entire cultures grew upon this predictable return. Cities and civilizations rose from sunlight, converted into grain. Even the fuels we burn today are sunlight from the deep past. Coal, oil, and gas are compressed remains of ancient plants and plankton, their energy locked away over millions of years. When we burn them, we are spending the savings of extinct ecosystems, drawing from an ancient trust fund set aside by time. The warmth of a fire, the movement of a car, the glow of a city's lights, all are echoes of photons that once fell on long-vanished forests and seas. Seen this way, the sun is not only a distant light but the heartbeat of Earth's systems. Every forest, reef, and meal exists because of its steady investment. And unlike any human financier, the sun never misses a payment. For billions of years, it has delivered its wealth without fail, shaping every pattern of weather and every form of life. What makes this arrangement remarkable is its generosity. The sun asks for nothing. It does not keep records or demand repayment. It simply radiates, sending its energy across space. Earth receives that gift and turns it into color, motion, and sound, the music of life. To feel sunlight on your skin is to touch that ancient transaction still unfolding. It is warmth that has traveled across the void, the same warmth that drives winds, stirs oceans, and powers the tiny engines inside every leaf. It is the steady pulse of the solar economy, the quiet transfer that keeps our world alive. From there, the chain continues inward. The energy that begins in the heart of the sun filters through atmosphere and soil, through plant and food, until it reaches the smallest scales of life. Inside every living cell, far smaller than the reach of sight, the same story plays out in miniature. Proteins fold into precise shapes, membranes shift and ripple, signals pass like whispers through a crowded marketplace, molecules trade places, collide, and drift apart in a ceaseless rhythm. None of this activity is free. Just as a city runs on currency, the cell runs on its own form of payment. That currency is a molecule called ATP adenosine triphosphate, the coin of life's economy. ATP is small, quick, and endlessly useful. It is built from a base molecule linked to 3 phosphate groups. each carrying a charge that pushes against the others like compressed springs. Break one of those bonds, and a burst of energy is released. That is why ATP is perfect for life. It can be spent in small, measured amounts. A cell doesn't need to ignite a blaze to move a single molecule. It only needs to spend one ATP coin. Imagine having pockets full of small change instead of carrying a single heavy bar of gold. With coins, every small purchase is possible. Inside your body, trillions of cells are producing and spending ATP at every moment. The scale is astonishing. Over the course of a day, your body produces roughly its own weight in ATP, minting and spending continuously. Picture an invisible marketplace humming under your skin. A molecular pump uses a few ATP coins to move sodium and potassium ions across a membrane. A contracting muscle fiber spends thousands at once to lift your arm. Even the firing of a neuron in your brain draws from the same purse. Every thought, every blink, every heartbeat has an energy cost paid for in ATP. To understand this budget, think of metabolism as an intricate market. The food you eat is broken down into glucose, fats, and amino acids, the raw deposits of energy. Inside cells, these raw materials enter a network of reactions: glycolysis, the citric acid cycle, and oxidative phosphorylation. Together, they refine, process, and convert the incoming energy into ATP. Once made, ATP does not sit in vaults. It circulates instantly, earned and spent in a rhythm that never stops. Life depends on this continuous flow. Cells manage this economy with remarkable care. They do not overproduce if the demand is low, nor do they waste energy on excess. When activity increases, they accelerate ATP production. When you rest, they slow it down. Sprinting is like a sudden rush on the bank, with your cells racing to print enough ATP to pay for your muscles' demands. Rest is the quiet hour, when production steadies, maintaining balance with what is needed. If ATP is the coin, the mitochondria are the mint. These tiny organelles, often called the powerhouses of the cell, are where most ATP is produced. Inside their double membranes, electrons taken from food molecules travel along a chain of proteins. Each step releases a little energy, which pumps protons across the membrane, building up an invisible dam of charge. As the protons flow back through a molecular turbine called ATP synthase, the machine turns and new ATP molecules are forged. It is a scene of silent industry, billions of microscopic turbines spinning in unison, powered by food and oxygen, keeping life in motion, one coin at a time. The beauty of this system lies in its continuity. Every breath brings oxygen into your lungs. Red blood cells carry it to tissues where mitochondria wait. There, oxygen acts as the final receiver of electrons, allowing the entire chain of reactions to keep running. Without oxygen, the mint stalls, and ATP production falls sharply. This is why oxygen feels so vital. It is the unseen auditor of the body's economy, ensuring that every account remains open and balanced. Cells can also adapt to changing supply. Glucose is the preferred fuel, but not the only one. When food is scarce, fats are converted into ATP through different routes. Proteins, though less efficient, can be broken down for energy in emergencies. During intense effort, when oxygen runs low, cells switch to fermentation, producing ATP quickly but wastefully, like taking out a short-term loan at high interest. Every method exists to serve one purpose: to prevent bankruptcy at the cellular level. Life cannot tolerate a missed payment. Every movement, every breath, every spark of thought depends on this endless exchange. Even in stillness, ATP coins are being spent. Your cells pay for repair, transport, and balance. The warmth of your body on a cold night is the quiet result of countless ATP molecules being cashed in to maintain temperature. True rest, at the cellular scale, is simply a slower market, never a closed one. ATP's role is universal. It is not a human invention or a unique feature of animals. Plants, fungi, bacteria, and every known form of life rely on the same coin. They produce it in different ways, some from sunlight, some from chemical reactions, but the end result is identical. Evolution discovered ATP early and never replaced it. The design was too efficient, too elegant, too adaptable. Across billions of years, the currency of life has remained unchanged. Every living being, from a blade of grass to a blue whale, pays its energy bills in the same small units. The rates of spending, however, vary wildly. A hummingbird burns through ATP at a dizzying pace just to keep its wings vibrating fast enough to hover. A dormant seed deep in the soil spends almost nothing, saving its reserves for the right moment to sprout. Cells, like societies, show diversity in how they handle their budgets. Some live frugally, others lavishly, but all are bound by the same rules of exchange. This hidden economy is reassuring in its order. Beneath thought and movement lies a constant hum of activity, so steady and universal that it unites all living things. Each breath of oxygen, each bite of food, is translated into countless molecular payments. Without realizing it, you are the sum of these invisible trades. A living economy built from endless, precise transactions. ATP may be a chemical, but thinking of it as currency captures its role perfectly. It is the coin spent on every heartbeat, every neuron's fire, every dream that drifts through sleep. A single molecule is tiny, but multiplied across the trillions of cells in your body, it becomes an ocean of energy in motion. Life runs not on miracles, but on bookkeeping. Energy moves through systems as transactions, from sunlight to sugars, from food to fuel, from ATP to motion. Every organism participates. The story begins again with the producers, plants, algae, and bacteria that capture sunlight and convert it into sugars. They are the investors, creating wealth that sustains all others. Without them, no animal, fungus, or human could exist. Every blade of grass, every leaf on a tree is a mint of stored sunlight, quietly gathering deposits every day. Next come the consumers, who spend what producers earn. Herbivores feed on plants, turning stored sunlight into muscle and movement. A rabbit nibbling on clover or a cow grazing in a field is drawing from the solar account. Yet only a fraction of the original energy transfers onward. Most is lost as heat or used for the animal's own metabolism. When a fox eats the rabbit or a human drinks milk from the cow, the energy has already been spent many times. Each exchange carries a cost. This is why food chains form pyramids. Plants at the base capture the most energy. Herbivores pass along less. Carnivores pass along even less still. Energy leaks away with every transfer, mostly as heat. There can never be as many predators as prey, nor as many prey as plants. The math of energy demands this balance. A savanna holds vast fields of grass, herds of grazing animals, and only a few lions. The pattern repeats in forests, oceans, and skies. The pyramid of life, is not a symbol of power, but of efficiency. It reflects the limits of energy flow. Decomposers complete the cycle. Fungi, bacteria, and scavengers reclaim what others leave behind. They break down fallen trees, animal remains, and waste, returning nutrients to soil and sea. Without them, the system would clog with debris. Decomposers are the quiet accountants of the biosphere, ensuring nothing valuable is wasted. They close the loop, keeping the energy books balanced and ready for the next round of life. This cycle has curious side effects. Consider a lion. It cannot live on grass, not because grass lacks energy, but because the lion's digestive system cannot access it. Herbivores are experts at breaking down plant material, often with the help of bacteria in their stomachs. Lions rely on those herbivores to do the hard work first. In effect, they outsource digestion, consuming concentrated energy that has already been processed. The inefficiency of transfer limits their numbers and defines their place in the world. If energy passed perfectly, the planet would swarm with predators. Instead, the losses enforce balance. Grasslands must stretch wide to feed herds of zebras, which in turn support only a handful of lions. Oceans teem with plankton and fish, but only a few sharks rule their depths. The structure is stable because the flow of energy shapes it that way. Each chain of exchange links back to the same source. Sunlight, a leaf absorbs light. A caterpillar eats the leaf. A bird eats the caterpillar. A hawk eats the bird. When the hawk dies, decomposers return the matter to the earth, feeding the roots of trees that grow new leaves. The line circles back on itself, forming the endless loop that defines life. Nothing is ever wasted, only changed. Humans fit neatly within this cycle. When we eat plants, we draw energy directly from the sun's investment. When we eat animals, we take energy that has passed through several hands. The higher up the chain, the more energy has been lost along the way. It is why growing crops feeds more people than raising livestock on the same land. Each additional step costs energy. The physics of digestion and metabolism set the limits of agriculture and diet alike. Even with these inefficiencies, the system thrives. Energy does not need to move perfectly. It only needs to move continuously. The balance between producers, consumers, and decomposers keeps the world alive. Forests grow, grasslands pulse with herds, oceans shimmer with fish, all because sunlight enters the system and never stops circulating. The flow is steady, graceful, and self-correcting. To step back and look at this pattern is to glimpse a quiet order beneath the surface of life. The sun sends its light, plants capture and invest it, animals spend and move it, decomposers recycle what remains. The cycle repeats endlessly. Each moment of motion, each breath, each heartbeat is part of this ancient exchange. Energy, shaped into life and reshaped into light again, passes from hand to hand, never lost, only transformed. Every meal you eat is a piece of that story, a fragment of sunlight that journeyed through leaves and creatures before becoming part of you. You are, in every sense, a participant in the grand economy of life, the ceaseless marketplace where energy changes form but never disappears. Over time, that same flow did more than sustain life. It shaped it. Energy not only moves through ecosystems, it sculpts the forms that depend on it. The struggle to capture and conserve energy became the engine of evolution itself. Evolution is often described as a contest of survival, a drama of claws, speed, and instinct. Yet beneath those vivid scenes lies a quieter, universal story, the story of energy. Every organism, from the smallest microbe to the largest whale, must answer the same three questions: how to gather energy, how to store it, and how to spend it. Evolution is, in many ways, the history of life's budgeting strategies. Across billions of years, every species has been shaped by the same pressure to make the most of limited resources. The shape and size of every body are written by those rules. Large animals enjoy strength and stability, but they must find enormous amounts of food to keep moving. Small animals live faster, burn hotter, and eat often, surviving on constant motion. Neither path is better. Both are solutions to the same accounting problem. Energy determines form as much as it sustains it. Dinosaurs provide striking examples of this balance. The great sauropods, such as Brachiosaurus, towered over the landscape with bodies that demanded vast quantities of food. Their long necks were not just for show. They were tools of efficiency. With a slow sweep of the head, a sauropod could graze across a wide area without moving its massive frame, saving precious energy that might otherwise be spent walking. Predators like Tyrannosaurus rex faced a different challenge. Chasing prey at random would waste energy faster than they could replace it. Their bodies, built for bursts of power, favored patience. They struck rarely, only when the odds of a clean, high-energy meal were worth the cost. At the other extreme were small feathered dinosaurs, ancestors of modern birds who gambled on flight. Flying consumes immense energy, but it opens doors to new food sources and safer habitats. To afford it, they evolved light bones, efficient lungs, and strong hearts. It was a high-risk, high-reward investment that still pays off today in every sparrow and eagle. Evolution, it seems, rewards creativity in how life spends its energy. Few creatures demonstrate that creativity better than the hummingbird. Its wings beat nearly 80 times per second, holding it steady as it hovers before a flower. This delicate balance costs dearly. To fuel that constant motion, the bird must eat more than its own body weight in nectar each day. Its metabolism is so fast that its heart can beat over 1,000 times a minute. When night falls and flowers close, the hummingbird faces an energy crisis. Its solution is torpor, a nightly slowdown that lowers body temperature and conserves power. Without this pause, it would not survive until morning. Every dawn is a new calculation, a tightrope walk between energy spent and energy earned. Humans tell a different version of the same story. Our brains, though small in mass, consume a staggering portion of our energy budget, roughly 1/5 at rest. Each thought, memory, and decision is a costly act paid for in calories. To sustain such an expensive organ, our ancestors evolved ways to gather and manage energy more efficiently. Walking upright freed the hands for tools. Cooking made food easier to digest, unlocking more energy from each meal. Cooperation allowed groups to hunt, share, and store resources more safely. Even culture itself, the exchange of knowledge and labor, became a way to stabilize the energy supply for our demanding minds. Energy shapes behavior as much as it shapes bodies. Predators must weigh the cost of the chase against the value of the meal. A cheetah that sprints too often without success risks collapse. Hyenas, by contrast, conserve strength through teamwork and endurance, relying on group effort to outlast their prey. Grazing animals face their own equations, balancing the need to eat against the danger of being eaten. Migration, too, is an act of energy calculation, a long journey towards seasonal abundance, where the promise of future resources outweighs the cost of the trip. Even beauty obeys these laws. Courtship displays, songs, and dances are more than romance. They are public proofs of surplus. A bird that can afford to sing or spread brilliant feathers is one whose energy budget is healthy enough to spare for elegance. In the marketplace of evolution, extravagance is advertisement. Efficiency, then, becomes the real measure of success. Evolution trims the wasteful and favors the wise spender. Cheetahs run fast but briefly. Lions conserve power by resting for much of the day and striking only when success is likely. Each survives within its balance sheet. The rule is universal: never spend more than you gain. Plants follow the same logic, though their transactions are measured in sunlight and water instead of motion. Desert cacti, with thick skins and narrow leaves, hoard moisture and minimize loss. In rainforests, broad leaves spread wide to catch every stray photon of light filtering through the canopy. The shape of a leaf, the thickness of bark, even the timing of a flower's bloom, all are expressions of energy budgeting. Where energy is scarce, life grows lean. Where it is plentiful, life grows lush. The principle behind all of this can be stated simply: evolution favors those who manage energy well. The hummingbird thrives by pushing metabolism to the edge, balanced by nightly rest. The lion endures through patience and conservation. Humans prosper by stretching every calorie further, transforming raw materials into cooked meals, shared hunts, and cultivated crops. Each success is an adaptation to the same invisible rule, the economics of existence. Every creature is born into a world of limits. Wings, claws, roots, and brains are all investments shaped by those limits. What we see around us, the curve of a dolphin, the armor of a beetle, the grace of a hawk, is the outcome of countless trials in spending wisely. Evolution is not random chaos, but a long negotiation with energy. It decides what thrives, what fades, and what persists across ages. To live is to spend. To last is to budget well. Among all living things, one species began to play the energy game in a new way. Instead of relying solely on the body's design, humans learned to extend their reach through tools, cooperation, and curiosity. They did not evolve sharper claws or thicker fur. They evolved understanding. Step by step, they began to uncover how energy could be guided, stored, and transformed beyond the limits of flesh and bone. There are moments in human history when everything changes, when survival becomes something larger, richer, and more deliberate. One of the greatest of these moments came not with the invention of the wheel or the shaping of stone, but with the taming of fire. Fire was more than a light against the dark. It was the first true energy revolution, a discovery that reshaped the path of our species. To early humans, fire was both miracle and mystery. It could destroy a forest or warm a cave. It was wild, yet it could be controlled. Its glow could turn night into day, fear into safety. Cooking was fire's most profound gift. Raw food contains nutrients, but unlocking them takes effort. It demands chewing, long digestion, and wasted energy. By cooking, early humans broke tough fibers, softened roots, and released calories that could be absorbed quickly. It was the first major improvement in the efficiency of life. More energy gained, less energy spent. Anthropologists suggest that this change may have fueled the growth of larger brains. A raw diet traps time and energy in digestion, but a cooked one frees both. The hours once spent chewing could now be spent thinking, shaping tools, and forming social bonds. Fire did not just make food easier to eat, it made thought itself more affordable. Beyond nourishment, fire offered warmth. In cold climates, it turned harsh landscapes into habitable homes. It allowed migration into regions once impossible to endure. A small flame meant safety, comfort, and endurance through the seasons. With fire, people could settle where animals could not. It was a passport to the wider world, and it was a shield. The flicker of flame kept predators at a distance. Wolves and big cats hesitated before its glow. A campfire was a circle of safety, the earliest fortress against the unknown. Fire also became a gathering place. Around it, shadows moved. Stories were told, and language took root. In the light of flame, people saw each other's faces and shared their first myths. Laughter, song, and imagination bloomed in its warmth. Fire changed not just what humans ate, but who humans were. Before fire, night meant stillness. After fire, night became a time for thought and connection. The day no longer ended with the setting sun. It continued in the glow of embers. This extra time shaped the human mind as much as any tool or weapon could. Tending fire demanded discipline. Sparks needed shelter. Wood needed gathering. And flames required guarding. To let a fire die could mean danger or death. The responsibility gave rise to early customs rituals that treated fire as sacred. In many cultures, keepers of fire were honored, entrusted with maintaining the flame that sustained the community. Fire became not only a necessity, but a symbol of continuity, passed carefully from generation to generation. As knowledge grew, fire's uses multiplied. It hardened clay into pottery, allowing food and water to be stored. It smelted metal from rock, birthing tools and weapons that reshaped human power. It cleared land for crops and for settlements. Each new use extended human reach. Fire was industry before the Industrial Revolution, science before laboratories. From blacksmiths hammering molten iron to glassmakers shaping sand, the same principle held. Energy could transform matter. The spark that once came from lightning or volcanoes became something carried, protected, and shared. Early travelers moved across continents with bundles of smoldering sticks, ensuring that no night would ever be completely dark again. The myths that formed around fire recognized its dual nature. In Greek legend, Prometheus defied the gods to bring fire to humankind, a symbol of rebellion and progress. In many traditions, fire was a divine gift or a dangerous secret, too powerful to be taken lightly. The stories capture a truth. Fire was not just a tool, it was a turning point. It transformed humanity's relationship with energy. For the first time, people did not just receive power from nature, they managed it, directed it, and made it their own. Even in the modern world, surrounded by electricity and engines, the pull of fire remains. Campfires still gather people together. Candles still burn at ceremonies and vigils. Flames still mark moments of reflection, celebration, and remembrance. Fire is no longer essential for survival, but it still speaks to something ancient. It is a symbol of life, warmth, and connection that echoes from the first hearths to the last power plant. The first fire tended by human hands was more than warmth against the cold. It was a promise that life could reach further, that energy could be shaped, stored, and shared. It was the first true partnership between humanity and power. From fire came the next great transformation: agriculture. If fire was the first step in mastering energy, farming was the second, the art of storing sunlight. Before agriculture, people lived as hunters and gatherers, moving with the rhythms of the land. Food was uncertain, appearing in bursts of luck and season. Energy came and went like weather. Then, quietly and gradually, humans learned to plant seeds and tend them. It was an innovation as radical as fire, though far less dramatic. Farming was the deliberate capture of solar energy on a grand scale. It was the moment when people began to create their own sources of abundance. Plants, as always, performed photosynthesis, turning sunlight into sugars and starches. But now, instead of leaving this process to nature, humans guided it. They cleared land, planted rows, and protected fields. They built the first controlled systems of energy collection fields that acted like living solar panels. A harvest was stored sunlight, concentrated and portable. A sack of grain was not just food, but a bank of calories, a reliable account of energy to be drawn upon later. This shift changed everything. For the first time, people could save energy in quantity. A successful harvest meant surplus calories beyond immediate need. That surplus freed time and imagination. Some people could now specialize: builders, toolmakers, storytellers, and priests. The energy stored in crops supported the rise of villages, cities, and civilizations. It funded art, religion, and invention. Surplus food became surplus thought. Grain became the foundation of this new system. Unlike fruit or meat, it could be dried, stored, and moved across distances. Wheat, barley, rice, and maize became forms of currency. Temples collected grain as taxes or offerings. Governments counted wealth in granaries. Armies marched on grain rations packed for long campaigns. Ancient records carved into clay tablets showed detailed lists of barley paid as wages. Along the Nile, the power of pharaohs rested on the full granaries that lined the riverbanks. Across the world, dynasties rose on the strength of rice and wheat. Calories were power, and farming was how humans learned to hold it in their hands. A single person needs only a few thousand calories each day, but multiply that by thousands, and the scale becomes enormous. Agriculture turned unpredictable energy into measurable wealth. Stored grain became the foundation of stability, a safeguard against famine, and a way to plan for the future. It also demanded new systems of control. Granaries needed protection, fields required irrigation, and people had to coordinate labor. In managing food, humans invented administration. Bureaucracy, law, and leadership all grew from the need to track and distribute stored energy. The beauty of farming lay in its scalability. A small family could manage a garden. Entire civilizations could manage river valleys. The more fields, the greater the flow of sunlight into society. Innovations like irrigation, the plow, and crop rotation were not just tools of agriculture, they were amplifiers of energy. Each new method increased yield, feeding more people, enabling more work, and driving more discovery. Human history became a record of learning to extract, store, and spend the sun's power. Abundance, however, brought new challenges. Diets narrowed as societies came to rely on a few crops. Wheat, rice, and corn provided dependable calories, but less variety. Health declined in some places even as food security grew. Farming also tied people to cycles of planting and harvest. It required hard labor and constant attention. The freedom of foraging gave way to the discipline of agriculture. Yet despite its costs, the benefits were undeniable. The steady storage of energy made possible everything else that followed population growth: cities, writing, trade, and technology. Agriculture was more than survival. It was civilization's engine. Every great monument, from pyramids to cathedrals, was built by hands sustained on grain. Every voyage, invention, and empire rested on stored sunlight. Even today, the connection remains. Our global economy runs on electricity and fuel, but its base is still agriculture. The food in markets, the bread on tables, the rice in bowls, all are direct descendants of that first deliberate act of cultivation. The fields of today are the modern granaries of sunlight, feeding billions through the same simple miracle. In the quiet logic of farming, there is poetry. To grow crops is to turn light into life, to transform fleeting rays into lasting form. Every seed sown is an act of faith that the energy will return multiplied. Every harvest is a reminder that humanity learned, long ago, to manage nature's wealth rather than merely chase it. Agriculture was the moment when energy stopped being a gift and became a partnership. The fields became vaults, the granaries became banks, and grain became both food and currency, shaping the destiny of our species in ways still felt with every meal we share. Beneath the ground, hidden under layers of rock and time, lies an ancient treasury. It is a storehouse of energy so vast that it was built long before humans ever walked the earth. Coal, oil, and natural gas are not just materials. They are condensed history, sunlight captured by ancient forests and plankton, transformed and sealed away over hundreds of millions of years. When humans learned to dig, drill, and burn these buried riches, the world changed forever. It was as if we had stumbled upon an inheritance from the deep past and decided to spend it all at once. To understand fossil fuels, imagine the planet 300 million years ago. The continents were draped in enormous fern forests and steaming swamps. Plants drank in sunlight and stored it in their tissues just as they do now. When these plants died, some were trapped under layers of mud and water instead of rotting away. Over immense spans of time, heat and pressure compressed them into coal. In the ancient seas, drifting plankton and algae followed a similar path, settling into sediments that hardened into oil and natural gas. Every lump of coal, every droplet of crude, every invisible puff of methane is fossilized sunlight energy from vanished ecosystems, pressed into the Earth's crust and forgotten until we uncovered it. For most of human history, this treasure lay untouched. People burned wood for warmth, used their own strength for labor, and captured small amounts of power from wind and water. Life ran at the speed of muscle and season. Then, in the late 18th century, coal began to change everything. With it came the steam engine, a machine that turned stored sunlight into motion. Coal-powered trains that crossed continents, factories that spun textiles and steel, and pumps that drained mines once thought too deep to reach. Work that once took days could now be done in hours. It was as if the world had found a shortcut through time. Oil followed, more versatile and portable. Refined into fuels, it powered ships and automobiles, lit lamps, and later fed the engines of flight. It lubricated machines and, through chemistry, gave rise to plastics fertilizers, and medicines. Natural gas joined the story, providing cleaner heat and driving turbines for electricity. Together, these fuels formed a foundation for modern civilization. Cities glowed through the night, industries expanded, and food production soared. The energy of ancient life propelled the modern age forward at a pace no generation before could have imagined. The abundance of fossil energy gave the illusion of endless growth. Machines multiplied, populations surged, science and medicine advanced faster than ever. A single barrel of oil contained as much energy as weeks of human labor, and billions of such barrels were soon flowing through the arteries of global trade. It felt as though the world had found perpetual motion. Humanity had discovered not just a fuel, but freedom from limitation. But the supply was not infinite. Every ton of coal, every barrel of oil, every cubic meter of gas was a withdrawal from an account that took millions of years to build. What the Earth had stored slowly and patiently, humans burned in the blink of geological time. We lived for a few centuries on the concentrated savings of ancient sunlight, and in doing so, we began to change the planet itself. The transformation came with a cost that was not immediately visible. When fossil fuels burn, they release carbon dioxide, the same carbon once absorbed by ancient plants. For eons, that carbon had been locked safely underground. Its cycle paused. By releasing it back into the atmosphere, we disturbed the balance that shaped Earth's climate. The result is a warming planet, rising seas, shifting weather, melting ice, and storms that carry the weight of imbalance. Fossil fuels gave us power, but they also created a debt, an environmental tab, now coming due in the language of floods, droughts, and fire. The irony is clear. The very qualities that made these fuels so valuable, their density, reliability, and abundance, also make them perilous when overused. They are sunlight in its most concentrated form, compressed by time. To burn them is to release the energy of entire ancient worlds in an instant. Every flick of a switch, every turn of an ignition key, is a tiny act of spending from this ancient account. One light bulb's glow is powered by the death of a forest that fell hundreds of millions of years ago. Each engine that roars to life resurrects the chemistry of forgotten seas. It would be wrong to see fossil fuels only as villains. They lifted billions out of poverty, extended life expectancy, and built the infrastructure of the modern world. They heated homes, carried food and medicine across oceans, and powered hospitals and schools. They made possible the technologies that allow humanity to understand the universe itself. The problem lies not in the discovery of fossil fuels, but in their unchecked consumption. We mistook abundance for infinity and convenience for permanence. Thinking of fossil fuels as ancient sunlight changes how we see them. A piece of coal is a compressed forest. A drop of oil is the liquefied memory of plankton that drifted in prehistoric seas. The flame of a gas burner is the brief return of ancient energy to the surface world. It is both humbling and unsettling to realize that much of modern life runs on the energy of vanished ecosystems. The past, in a very real sense, fuels the present. Now humanity stands at a turning point. The reserves that built our civilization are finite, and their effects are global. The sky itself carries the record of our burning, a rising curve of carbon that marks our acceleration. We face a choice between continuing to draw down this inheritance or learning to live within a renewable budget. The question is no longer about whether fossil fuels can sustain us, but whether we can transition before their side effects overwhelm the systems we depend on. It is humbling to remember that every spark in a factory, every hum of a motor, every glow of a city at night traces back to the quiet work of ancient plants and plankton. They captured sunlight, died, and were buried, leaving behind a savings account of energy that their distant descendants would one day discover and consume. Humanity inherited their gift and spent it with astonishing speed. The story of fossil fuels is both triumph and warning. It is the story of how a species learned to harness the deep past, and in doing so, changed its own future. Coal, oil, and gas still power much of the world. Their glow still fills cities. Their engines still drive ships and planes. Their heat still cooks our food. But their chapter is reaching its limit. They remind us that energy is never truly free. It always carries a cost, sometimes hidden, sometimes delayed, but always real. Out of this realization grew the next great step in the human energy story: electricity. Of all forms of energy, it is the most flexible, the most obedient, and the most mysterious. Flick a switch, and a room blooms with light. Plug in a machine, and it comes to life. Send a message across the world, and it travels at nearly the speed of thought. Electricity feels instant, almost magical, yet it is governed by the same principles that shape every exchange of energy. The story of electricity began not with industry, but with curiosity. Ancient thinkers noticed that rubbing amber produced small sparks, or that lightning struck with blinding force. But for centuries, such effects were treated as wonders, not tools. In the 18th and 19th centuries, experimenters began to uncover their secrets. They learned to generate electricity, to store it, and eventually to control its flow. Once tamed, it moved from spectacle to necessity. The light bulb marked electricity's first great revolution. With a thin filament glowing inside glass, darkness itself became optional. The day could extend indefinitely, free from the setting sun. Streets became safer, factories ran through the night, and homes glowed with steady brilliance. The light bulb was more than a convenience. It was a symbol of mastery, proof that invisible forces could be shaped to human will. Electricity's true genius, however, lies in its versatility. The same current that lights a bulb can power a motor. Motors convert electricity into motion quietly, cleanly, and instantly. They pump water, drive trains, run assembly lines, and turn fans. From the tiny motor in a watch to the engines of vast ships, the principle is the same: ordered electrons made to do work. Unlike steam engines that needed heat, fuel, and time, electric motors deliver power on command. They made motion itself as easy to summon as light. Electricity also transformed communication. The telegraph carried messages as pulses across continents, shrinking distance to a heartbeat. The telephone turned signals into voices. Radio spread music and news through the air. Later, computers and the internet would ride those same electrical currents, linking billions of people in real time. Electricity turned the planet into a single network, connected by invisible threads of energy. At the heart of this system lies the grid, a vast and intricate web of wires and transformers that moves electricity from where it is generated to where it is used. Imagine a marketplace where the currency is electrons, constantly exchanged between suppliers and consumers. Power plants feed the grid, homes and industries draw from it, and every moment must be balanced. Too much or too little current, and the system falters. Yet for most people, it feels effortless. Flip a switch, and the current flows, steady and silent. Electricity's adaptability explains its dominance. It can be turned into light, heat, sound, or motion with ease. It powers the tools of medicine, the circuits of computing, and the rhythms of modern life. Yet it cannot be stored easily at large scales. It must be produced as it is consumed, a constant dance of supply and demand managed by engineers and algorithms around the clock. When millions boil water for morning tea or turn on evening lights, generators far away adjust their output in perfect coordination. This invisible choreography has changed how humans live. Nights are no longer dark. Work and leisure flow together under artificial light. Cities reach upward, powered by elevators and electric pumps. Subways and trains move millions each day, all sustained by the hum of electrical current. The cycle of day and night, once fixed by nature, now bends to the will of human schedules. Electricity gave civilization control over time itself. For all its power, electricity remains unseen. The wires are still, the sockets plain, the current invisible. Yet through them flows the energy that sustains the modern world. Billions of electrons, smaller than atoms, drift in silent order, carrying our voices, lighting our homes, and driving the wheels of progress. In them, the long story of energy, fire, sunlight, fuel finds its most flexible form. It is astonishing that something so small, so intangible, could hold the weight of human civilization. And yet it does. Today, almost every moment of modern life runs on the hum of electricity. From glowing towers and lit streets to phones that whisper across oceans, every comfort and connection depends on the same invisible current flowing through wires. It is energy on demand, summoned by a switch, spent in a heartbeat, and renewed every second. In this quiet flow lies the most versatile currency ever created: electricity, the medium that allows energy to take any shape we need. To walk through a city at night is to see this current made visible. Neon lights, moving trains, the steady pulse of life, powered by electrons in motion. Electricity has become the universal currency of civilization, the thread tying together every machine, every home, every act of communication. Yet behind it all lies something deeper, the original economy that makes all others possible, the economy of energy. Before there was money, there were calories, heat, and motion. Energy has always been the real wealth, the power to make things happen. Coins, paper, and digital numbers only measure that wealth. They do not create it. A vault filled with gold cannot light a single bulb or turn a single wheel without energy behind it. In the end, every fortune depends on the capacity to capture, store, and use energy. The parallel between money and energy runs deep. Calories are the body's currency. Spend too many, and you grow weak. Save too many, and you carry the weight of unused reserves. The principle is the same as in any economy. Balance sustains life. In physical terms, a watt is a measure of how fast energy is spent. In human terms, wealth measures the ability to do work, to build, to move, to create. A rich society is one that can transform its stored energy into buildings, machines, and art. The wealth of nations, whether measured in coins or kilowatts, has always reflected the same truth, that energy makes everything possible. Ancient economies understood this instinctively. Wealth was counted not in abstract symbols, but in tangible energy sources. A sack of grain was both food and currency, calories stored for the future. Land was valued as a collector of sunlight, a surface that turned light into crops. Livestock were walking batteries, holding energy in muscle and fat, pulling plows and carrying goods. Even when coins appeared, Their worth came from what they could command: bread, labor, warmth, all of it measured in energy. Every transaction was a small exchange in the great flow of sunlight through human society. As economies became more abstract, the connection faded from view, but it never disappeared. Today, paychecks are written in numbers, but those numbers translate into electricity bills, fuel tanks, and food cupboards. A salary is a stream of energy measured in financial form. Governments speak of GDP in dollars or euros, yet what they truly measure is the rate at which societies convert energy into goods, motion, and comfort. Money is the shadow cast by energy use. Without energy, money is decoration, a promise that cannot be fulfilled. The Industrial Revolution made that link impossible to ignore. Wealth exploded not from gold mines or trade routes, but from coal seams. Steam engines and furnaces turned fossilized sunlight into mechanical work. The richest nations were those with the deepest coal beds, and later, the largest oil reserves. Even the outcomes of wars often depended on who controlled the sources of energy: oil fields, fuel depots, and shipping lanes. Energy determined the limits of empire, production, and growth. The more energy a society could command, the greater its reach. Efficiency became a new form of wealth. In a home, cutting wasteful energy use is like trimming unnecessary expenses. In an industry, efficiency multiplies profit by delivering more work for less fuel. For nations, it stretches their resources, giving them more stability and independence. Every improvement in engines, turbines, and insulation is a step toward better accounting in the great energy economy. To waste less energy is to extend one's wealth in real, measurable ways. It is easy to mistake money for power, but history reminds us that it is energy that truly governs what can be done. A country overflowing with currency, but lacking food, water, or fuel, cannot sustain itself. Conversely, a society with rich energy resources, even without large financial reserves, can thrive. The fertile valley, the windy plain, the river capable of turning wheels, these are the real foundations of prosperity. Energy is wealth in its purest form because it is the ability to bring about change. Even today, the health of global markets depends on energy. The price of oil, gas, and electricity affects the price of everything else. When energy becomes scarce or expensive, economies slow. The flow of money follows the flow of watts. Even the digital world, which seems weightless and free, rests on vast electrical foundations, servers, data centers, and networks all powered by steady streams of current. Every text, song, and video call is backed by real electrons racing through wires. Digital wealth, too, is paid for in watts. There is irony in how carefully humans manage money yet treat energy with casual disregard. We track every cent, balance budgets, and calculate returns, but flip light switches without thought. Food is wasted, engines idle, and heat escapes from uninsulated homes. If energy is true wealth, then we are often careless bankers, spending without noticing the account. Yet behind every simple act, every breath, every meal, every beam of light runs the same current that links life to the universe. The calories in your body are sunlight filtered through leaves. The electricity in your lamp is a chain of energy stretching back to the turbines, to the rivers, to the wind, to the sun itself. To think of wealth in terms of energy is to see the world clearly. Money is a symbol of potential. Energy is the substance that fulfills it. Every society, no matter how advanced, ultimately depends on the same equations of energy in and energy out. No amount of wealth can purchase energy that does not exist. Money can redistribute access, but it cannot create new energy. The true limits of civilization are not set by markets, but by the flows of sunlight, heat, and motion available to us. This truth has shaped every age, from the rise of farming to the age of fossil fuels. Civilizations rise when energy is abundant and fall when it runs thin. The Fertile Crescent prospered on rich soils and steady rivers. Britain's empire was powered by coal. The modern world grew on oil. Each era's wealth was written in its energy supply. Money may change hands, but energy writes the rules. Recognizing this does not diminish money's role, it clarifies it. Currency organizes human exchange. Energy sustains it. True wealth is not printed or stored in ledgers. It is sunlight caught in grain, water turned into power, and the calories that keep hearts beating. Coins and digital balances are reflections of this deeper truth, markers of how we move and distribute energy. The economy of money and the economy of energy are two sides of the same coin. One measures, the other makes real. Markets rise and fall, but the constant remains wealth begins and ends with energy, the one currency the universe truly honors. That understanding has led humanity toward a new chapter. For 2 centuries, we spent from ancient savings, burning coal and oil as though the vault were endless. Now, we are learning to live on the planet's steady income, the renewables that arrive fresh each day. Renewable energy is not about draining reserves. It is about harvesting the ongoing generosity of nature. Instead of raiding the deep accounts of the past, we are learning to live on the daily paycheck of sunlight, wind, and water. Solar power captures this perfectly. Every second, the sun delivers more energy to Earth than humanity uses in an entire year. Solar panels are quiet accountants of this wealth, converting photons into electricity with no smoke, no flame, no debt to repay. It is as if we have learned at last to live directly on the light that feeds us. Wind is another form of solar energy, born from uneven heating of the atmosphere. For thousands of years, it has filled sails and turned millstones. Today, giant turbines sweep across hills and coastlines, turning air currents into electricity. Each rotation is a graceful transaction between the sky and the grid, the old art of harnessing the invisible, refined to new precision. Hydropower, too, transforms natural motion into energy. Rain gathers in rivers and lakes, falls through turbines, and becomes light and heat. Unlike fossil fuels, the water keeps cycling, evaporating, falling, and flowing again. It is the original renewable, a gentle borrowing of gravity's pull. Even deeper lies geothermal energy, the planet's internal warmth, a legacy of its fiery birth and slow radioactive decay. Wells tap this ancient heat to generate electricity or warm homes, drawing from the Earth's endless inner pulse. Renewables are often praised for being clean, but their deeper meaning lies in balance. They mark a shift from extraction to cooperation, from consuming to aligning. Fossil fuels taught humanity to burn and exhaust. Renewables teach us to harvest and sustain. They ask for humility, the willingness to live within the rhythms of sun and season rather than fighting against them. In this new relationship, energy is borrowed rather than stolen, its cycles left intact. Of course, renewables bring challenges of their own. The sun sets, winds fall calm, Rivers change course. To thrive on nature's income, humanity must learn storage and patience, saving daylight in batteries, holding wind power in reservoirs, and distributing supply through smart grids. The task is not to command nature, but to synchronize with it. It is a new kind of intelligence and energy ethics built on balance. In truth, this shift is not entirely new. Long before coal and oil, humans lived as renewable creatures. They sailed with the wind, warmed themselves by the sun, and milled grain with flowing water. The change today is scale and sophistication. The old tools have become global systems, guided by science and engineering. Yet the principle is ancient: to live within the energy budget of the planet, not beyond it. There is something quietly elegant about this return: to power cities with sunlight, to move ships by wind, to warm homes with the Earth's own breath. These are not just technologies, but philosophies. They represent a maturity, an understanding that the true wealth of the world is not hidden underground, but shining above and flowing around us every day. The real revolution is not in the discovery of energy, but in remembering how to live with it wisely. To stand beneath a wind turbine is to feel the sky itself at work. Air that once brushed over oceans and mountains now turns steel blades that hum like slow music. To live in a home powered by solar panels is to live with the quiet knowledge that the sun, 93 million miles away, is a daily collaborator. To walk beside a river held behind a dam is to see gravity, one of the oldest forces in existence, transformed into light in a single living room. To rest in a geothermal spring is to feel the Earth's internal warmth, a reminder that beneath the crust, our planet still glows from its own birth. These energies are not distant or theoretical. They are immediate, physical, and intimate. They weave human life back into the deep, patient cycles of the planet itself. Renewable energy offers a kind of peace because it returns us to balance. It turns the future away from extraction and toward participation. Sunlight, wind, water, and heat are the incomes we can depend on, the steady flows that sustain rather than deplete. They remind us that wealth is not always something to store in vaults or extract from the ground. Sometimes wealth is the ability to live within the rhythm of what is already abundant. To use energy renewably is to live in partnership rather than conquest. It asks humanity to work with nature's currents, to borrow its power without breaking its cycles. This way of thinking is not just technical, but philosophical, a quiet admission that the truest abundance lies in harmony, not accumulation. That same principle governs the human body. Every living person is a small-scale model of the planet's energy economy. Even when you sit still, you are managing an invisible budget. Each breath, each heartbeat, each flicker of thought costs energy. The food you eat and the oxygen you breathe are transformed into fuel, distributed through a vast network of cells and chemical pathways. Metabolism is the accountant that never sleeps, tracking income and expenditure, making sure the system remains solvent. At its simplest, metabolism is the set of processes that convert food into usable energy. Carbohydrates, fats, and proteins are broken into molecules small enough for cells to handle. Inside those cells, enzymes and mitochondria perform the alchemy that turns glucose into ATP, the body's energy coin. Each molecule of ATP is spent in seconds to power a movement, a signal, or a thought. Every blink, every muscle twitch, every dream draws from this same cellular treasury. Even in silence and stillness, your body spends enormous amounts of energy keeping its systems running smoothly. What often surprises people is that the largest part of daily energy use happens when nothing seems to be happening at all. Your resting metabolic rate, the baseline cost of being alive, pays for the essentials: blood circulation, breathing, cell repair, and temperature regulation. Even at rest, the body burns thousands of calories a day simply maintaining the machinery of life. You are, in a sense, a city that never shuts down, with lights glowing in every neighborhood, pumps working, and workers quietly maintaining the streets. Among the organs, the brain is by far the most expensive tenant. Though it makes up only a small fraction of body weight, it consumes about 1/5 of the body's total energy at rest. Every thought, memory, and flicker of imagination is costly. Unlike muscles, the brain never stops working. It is always processing information, maintaining awareness, and storing experiences. Even during sleep, it remains active, replaying memories and adjusting internal circuits. The cost of consciousness is a constant demand for energy. This hunger arises from how neurons communicate. Each signal they send depends on tiny electrical charges, ions moving across membranes, and restoring those charges requires energy. Billions of neurons firing in delicate patterns create a power demand unmatched by any other organ. When you skip a meal, the fog that fills your mind is not simply hunger. It is your brain asking for payment in glucose and oxygen, reminding you that thought itself has a price. Muscles, too, are large spenders. At rest, they use little, but when activated, their appetite for energy spikes. Sprinting, lifting, or even standing in one position drains ATP rapidly, and fatigue sets in when supply cannot keep up with demand. Endurance training teaches muscles to use fuel more efficiently, but no matter how strong or fit, the rule holds: movement costs energy, and the harder you move, the more you spend. The body's energy management includes clever cycles of saving and renewal. Sleep is one of the most elegant. During waking hours, energy is spent freely on thought, work, and reaction. At night, metabolism slows. Energy shifts toward repair, memory consolidation, and immune defense. It is not idleness, but investment. Sleep is a nightly audit that resets the system, balances the accounts, and prepares you for the next day's transactions. Without it, the entire structure falters. The mind grows cloudy, decisions blur, and the body's repair crews fall behind. Fatigue becomes the body's way of calling in its debts. Eventually, the only cure is repayment deep, unavoidable rest. The body's flexibility with energy is what makes survival possible. In abundance, extra fuel is stored as fat, a biological savings account for leaner times. In scarcity, those reserves are drawn down, converted back into energy to keep vital systems running. This adaptability allowed humans to survive cycles of feast and famine for millennia. In the modern world, where food is rarely scarce, those same survival mechanisms can lead to excess storage. But the principle remains sound. Store when you can, spend when you must. Even emotions follow these patterns. Hunger makes us irritable because the brain senses energy debt. The pleasure of eating rewards replenishment. The drowsiness after a heavy meal signals energy being redirected toward digestion, mood, motivation, and even willpower are bound to this ebb and flow. What we call personality often reflects how energy moves through us, how quickly we spend it, how well we restore it, and how smoothly we balance our accounts. In a poetic sense, Every person is a solar-powered organism. The energy you spend began its journey as sunlight. Plants captured it in leaves. Animals and grains stored it. You consumed it and now spend it on thought, movement, and warmth. Each heartbeat is a small act of exchange between the cosmos and your cells. You are a marketplace of energy, transforming starlight into life. To live is to budget energy. To thrive is to spend it wisely. Energy does not stop at biology. It flows through culture and language too. We describe people as radiant, draining, vibrant, or burnt out. We talk about power in leaders, warmth in friends, and energy in rooms. The word currency itself comes from the idea of flow. From the same root as current, power moves through systems, whether electrical, social, or personal. When we say a crowd feels electric, we are acknowledging a shared rhythm, a synchronization of energies that can be felt but not seen. Cultures have always sensed this connection. Long before science measured joules or calories, people told stories of the sun, fire, wind, and water forces that fed and frightened them. Fire in particular carried sacred meaning. To keep a flame alive was to guard life itself. Across civilizations, eternal flames burned in temples and hearths. Even today, candles at ceremonies or flames at memorials symbolize continuity and vitality. Light, warmth, and motion remain universal signs of existence. Language continues this tradition in quiet ways. We speak of sparks of inspiration, burning passion, or a fire going out. We describe effort as energy invested and exhaustion as running on empty. These metaphors persist because they feel true. They link the physics of energy to the psychology of living. They remind us that to feel alive is to feel in motion, charged, engaged. Spiritual traditions express similar ideas through the concept of life force. The Chinese speak of qi, the Indians of prana, the Polynesians of mana. Though each culture frames it differently, the core idea is the same. Energy flows through and between all things. Practices like meditation, yoga, and Tai Chi aim to guide that flow, to conserve and balance it. Science can describe these practices in terms of breathing, circulation, and focus. Yet the metaphor of energy remains powerful because it captures an experience beyond measurement. The felt sense of being connected and alive. Energy metaphors even structure how we view time and effort. We talk about investing energy in relationships, fueling ambition, or recharging after rest. Burnout feels like a candle melting to its base. Inspiration feels like a spark catching flame. Motivation is the steady current that keeps us moving, while apathy is the power outage of spirit. These phrases are not poetic accidents, they are the language of physics translated into the language of life. Festivals and rituals across cultures celebrate energy in its most visible form, light. From Diwali to Hanukkah to Christmas, lamps and candles are lit to mark the triumph of brightness over darkness. The symbolism is both physical and emotional. It honors not just light as a phenomenon, but energy as a principle, persistence, renewal, and the capacity to endure. In dance and celebration, human bodies themselves become conduits of energy, transforming food, rhythm, and joy into movement that unites entire communities. When people move together, singing, dancing, laughing, they are sharing energy in its purest form, dynamic, radiant, and collective. In this way, energy threads through every level of existence. It is the pulse in our bodies, the spark in our stories, the glow in our festivals, and the hum in our machines. Whether captured by a leaf, a turbine, or a heartbeat, it is always doing the same thing, moving, transforming, connecting. From the metabolism of a cell to the rhythm of a city, from the dance of wind across turbines to the flicker of firelight in old myths, the story is one. Energy flows, and everything that lives, feels, or creates flows with it. Modern language is saturated with the hum of energy. We describe a performer who lights up the stage, a friendship that has chemistry, a conversation that sparks. We say a city pulses with life, or that a relationship runs out of power. These phrases have become so natural, we rarely pause to notice their origin. Electricity and vitality, voltage and spirit, current and connection, are metaphors borrowed directly from the physics that runs the world. Even our digital lives, though built on invisible code, hum with the same imagery. We speak of signals, connections, wireless waves carrying our thoughts like electric whispers across the air. Why does energy hold such sway over the way humans talk and think? Perhaps because it is both invisible and undeniable. You cannot see energy itself, but you witness its traces everywhere, in the flicker of firelight, the crash of waves, the rhythm of a heartbeat, the lift of laughter. It is the hidden pulse behind every change. A life without energy would be motionless, soundless, and still. To live is to move, and to move is to hold energy in some form. No wonder our imaginations cling to it so easily. Energy has always been our language for vitality and emotion. Ancient myths personified it as gods of fire, sun, and storm. Modern art still uses light and color as shorthand for feeling. The glow of candles, the spark in eyes, the heat of anger or affection, each borrows from the same physical truth. Energy is transformation. When we describe an idea as bright, we are repeating in metaphor what nature already knows. In fact, that illumination is change, that radiance is the sign of work being done. Across ages and cultures, energy has been humanity's chosen symbol for both power and connection. To say someone has good energy is to sense that their presence stirs motion in the world, that something within them flows outward. It is an intuition that movement, emotion, and life share a common current. This sense is not wrong. The physics that moves the stars is the same that beats in our hearts. What we feel as spirit or drive is, in its most elemental form, organized motion of atoms and molecules, energy shaped into thought. But the reach of energy extends far beyond any human metaphor. It is the foundation of the universe itself, the common denominator between galaxies, gravity, and light. The cosmos is a vast ocean of exchanges, a continuous web of transformation stretching from the smallest quark to the largest cluster of galaxies. Every point of light in the night sky is an account in this great economy, energy being spent, transferred, and renewed. A star, to human eyes, seems steady and serene, yet within, it is a storm of unimaginable intensity. Under crushing gravity, hydrogen atoms fuse to form helium, releasing torrents of energy as light and heat. That radiation pushes outward, balancing the inward pull of gravity. As long as this balance holds, the star remains alive, neither collapsing nor exploding, a perfect tension between pressure and release. The sun is a middle-aged example of this equilibrium, quietly spending its hydrogen fortune at a steady pace. Larger stars burn with extravagance. Their mass amplifies their pressure, and their cores fuse elements at frantic speed. They shine brilliantly for a few million years, mere blinks in cosmic time, before burning out. Smaller stars, the red dwarfs, live far more modestly. They sip their hydrogen reserves so slowly they could shine for trillions of years. In this way, every star reveals a different approach to the universal budget. Some live fast and spend freely. Others live slow and save every atom's worth of energy. Eventually, every star must settle its accounts. When the hydrogen dwindles, gravity gains the upper hand. The core contracts and heats until new reactions ignite, fusing helium into heavier elements like carbon and oxygen. The star swells into a red giant, its outer layers expanding and shedding into space. For small stars, this transition ends in a gentle exhale, a glowing nebula surrounding a white dwarf that cools slowly for billions of years. For massive stars, the ending is far less quiet. A supernova is the ultimate act of spending. In seconds, the core collapses and rebounds in an explosion so fierce it can outshine an entire galaxy. The energy released in that brief moment surpasses what the sun will emit over its whole lifetime. Yet this violence is the source of renewal. In that chaos, the heavy elements, iron, gold, silver, uranium, are forged and scattered. Every rock, every breath, every drop of blood on Earth contains atoms minted in ancient stars. The iron in human hemoglobin was once part of a stellar heart. The calcium in bones was fused in a dying sun. Each of us is a pattern of recycled starlight, assembled from the remnants of stellar explosions long before our planet existed. Galaxies are the marketplaces of this cosmic commerce. Billions of stars exchange energy and matter within swirling arms of dust and gas. Gravity gathers clouds, births new stars, and shapes their orbits. Supernovae return material to the galactic pool, feeding the next generation. At the center of nearly every large galaxy lies a black hole, a vault so deep that not even light can escape its pull. And yet, paradoxically, these dark centers often release more energy than all their stars combined, through jets of plasma that can stretch thousands of light years. Even in the regions of deepest gravity, energy finds ways to express itself, turning collapse into creation. Zooming out further, the entire universe is a grand balance sheet. Its opening act, the Big Bang, was a burst of energy so immense it created not just matter, but space and time themselves. From that first instant, energy has been changing form, spreading, cooling, and diversifying. The universe expands, stars ignite and die, galaxies collide and reform. Energy flows outward, always obeying one rule: it can never be destroyed, only transformed. This flow, however, carries a direction. The second law of thermodynamics tells us that while total energy remains constant, its quality degrades. Useful, concentrated energy like the fuel in a star or the charge in a battery inevitably disperses into less useful forms. Entropy increases. In cosmic terms, this means the universe is slowly but surely spending down its stores of organization. The process is not decay in a moral sense, but diffusion, the even spreading of possibility. Imagine a banquet at the dawn of time. The tables are heavy with dishes of energy, fresh and hot. Stars are born, galaxies swirl, reactions burn. With each exchange, The table empties slightly. The warmth fades. The air cools. No single act ends the feast. It simply grows quieter until all that remains is the faint aftertaste of heat. This is the eventual fate physicists call heat death, a future when energy is still present but so evenly spread that nothing more can happen. In that far, far epoch, so remote, it stretches beyond words like billion or trillion, no new stars will form. The last white dwarfs will cool to blackness, their heat radiated away. Neutron stars will drift through empty space, slowly losing what little energy remains. Even black holes, once the final storehouses of mass and power, will evaporate through Hawking radiation, vanishing into faint whispers of light. What remains will not be chaos, but calm, a universe in perfect equilibrium, uniform and silent. To call this the death of the universe is misleading. Nothing ends violently. There is no final explosion or collapse. It is more like the closing of a long day, the slow dimming of the cosmic lights as the work of eons concludes. Energy will still exist, but without gradients, it will have no story left to tell. Motion depends on imbalance, and when everything is balanced, time itself loses meaning. This vision might sound melancholy, but it carries a strange serenity. The universe began in heat and order, spent its energy on creation and complexity, and will end in peace. Every star that ever burned, every planet that ever spun, every life that ever felt joy or sorrow will have been part of this grand cycle of exchange. Entropy is not punishment, it is participation in balance. For human minds, accustomed to the brevity of decades, such time spans are almost incomprehensible. Yet in understanding them, a sense of gratitude arises. The temporary concentration of energy that allows Earth to exist, that drives weather, life, and thought, is extraordinarily rare. Against the backdrop of eternity, this brief, bright interlude is a miracle of imbalance. Stars shine precisely because they are not yet settled. Life thrives because it feeds on gradients, drawing from the uneven distribution of heat and light. Entropy, in its quiet way, reminds us to value the imbalance while it lasts. Every living system, every fire, every heartbeat depends on contrast, warmth against cold, light against dark, order amid flux. The universe's eventual calm gives meaning to the energy that still moves. The flame is beautiful because it will not last. The music of existence matters because one day it will fade. When we gaze at the stars, we are seeing energy in all its stages, spending, transforming, dispersing. The faint glow of the Milky Way is not just a view of space, but of history. Photons traveling across millions of years to reach our eyes. To look upward is to look backward, to witness the record of energy transactions written in light. Every twinkle in the night sky is both a distant event and an ongoing connection. The light that left a star before humans existed now ends its journey as a moment of awareness, completing a circuit that began before Earth was born. Energy, then, is the storyteller of the universe. It records its own passage in heat, in light, in memory. It builds stars, breathes life, and shapes thought only to return to stillness again. Nothing is truly lost. It only changes form, migrating from fusion to flame, from motion to warmth, from life to dust. The atoms of our bodies, the electricity of our minds, the warmth in our homes, all are temporary arrangements in a timeless current. Seen from this perspective, entropy is not the eraser of meaning, but the stage upon which meaning appears. Without dispersal, there could be no change. Without change, no story. The laws that guarantee the universe's eventual quiet are the same that allow stars to shine and minds to wonder. The end is written in the beginning, but between them lies the vast improvisation we call existence. The energy flowing through the cosmos today, the same that hums through cities, through neurons, through the hearts of stars, is part of one continuous act of transformation. We are participants in a drama far older than life, borrowers of radiance that once powered suns and will someday return to darkness. Every heartbeat, every breath, every spark of electricity is a small affirmation that the great current still moves. To live is to join that motion, to take part in the luminous expenditure that defines the universe itself. From galaxies blazing with power to the faint cooling of cosmic dust, every moment of energy's journey belongs to the same story. The universe will not end in flame, but in stillness, a long exhale after an age of motion. In that calm, all that has ever burned, flowed, or lived will remain, transformed into memory carried in the quiet hum of balanced energy. When people speak of impermanence in their own lives, they reach for cycles that bring comfort, the return of seasons, the rise and fall of tides, the turning of night into day. The fate of the cosmos may be no different, written across expanses so vast they humble imagination. Its stillness will not be emptiness, but completion, the grand balance reached after billions of years of exchange. The concept of heat death is less a warning than a lullaby. It whispers that nothing lasts forever, but everything has its place in the flow. Stars will spend their fuel. Galaxies will drift apart. Black holes will fade. And, at last, the universe will rest. In this long arc, humanity occupies a bright middle chapter, a moment when energy still rushes and shines, when the story is still being written in light. To live now is to exist in the peak of vibrancy, when the cosmos still dances with heat and form, when life borrows brilliance from the stars. Impermanence, seen this way, is not despair but wonder, the astonishment that the fire burns at all. Energy is not only the hidden engine of stars and cells, it is also the thread that weaves meaning into human life. Beyond equations and numbers, it becomes metaphor, a way of understanding movement, connection, love, and purpose. To speak of energy is to speak of vitality itself, the invisible rhythm that animates everything. Love, for instance, is described as a spark, a glow, a warmth, a flame that can ignite or fade. We reach instinctively for the imagery of energy because love, like light, cannot be seen directly but reveals itself through what it illuminates. Friendship, too, is often understood as an exchange of energy. Some relationships lift and renew, while others drain and deplete. Beneath the surface of words and gestures, we sense that something subtler moves between us, a current of attention, care, and presence, the flow of vitality from one life to another. Even motion itself, in both body and spirit, depends on that same current. A bird's flight is sunlight transformed into muscle. A dancer's leap is the poetry of metabolism turned to grace. A thought flashing through the brain is electricity organizing itself into meaning. Energy is the bridge between possibility and action, the medium through which stillness becomes movement, and potential becomes reality. Philosophers have long looked to energy as a mirror of existence. Some called it the vital force, the breath of the world. Others saw it as the eternal stream never created, never destroyed, only changing form. It reflects the rhythm of life and death, of joy and sorrow, of beginnings and endings. Nothing is ever truly lost. It simply shifts. The laughter of a child becomes the memory of age, just as the light of a dying star becomes the soil of a planet. The poetry of being lies not in permanence, but in transformation. Even silence carries energy, the heart beating quietly in the chest, the lungs rising and falling in rest, the faint spark of neurons dreaming. Stillness is not absence, but conservation, a pause between movements, the calm breath between waves. Sleep itself is a rehearsal of the universe's balance, a nightly restoration where energy regathers and prepares to move again. Beneath the quiet, the same laws hold: exchange, rhythm, continuity. Energy's beauty lies in its dual identity. It can be measured with perfect precision, joules, calories, watts, yet it also escapes the grasp of numbers, existing as warmth, inspiration, or grace. It is as real as the current in a wire, and as intangible as the comfort in a shared glance. It is the reason stars burn, and the reason someone seems to light up a room. Science and poetry meet in it easily. Energy belongs to both. When people say they feel drained, they describe more than fatigue. They speak of a dimming, a temporary absence of brightness. When they say they feel energized, they name that inner surge when the world seems possible again. In that sense, energy is both scientific and spiritual. It measures not only work, but aliveness, the degree to which existence feels vivid and awake. Across scales, the story stays the same. In the heavens, energy writes the history of matter. Stars fusing, galaxies spinning, black holes releasing their final breath. On Earth, energy writes the story of days. The warmth of sunlight on skin, the calories that feed motion, the thoughts that cross the mind, the laughter that ripples through air. Whether in galaxies or in hearts, the rule is constant energy flows, and through its flowing, life unfolds. To see energy as poetry is to see unity within diversity. The dance of fireflies over a summer field, the rhythm of tides, the quick flare of an idea, all are variations on one theme. The same current that builds storms in Jupiter's atmosphere also animates the human pulse. The body is sunlight rearranged. The mind is a pattern of electrical storms. The heart is a rhythmic engine that converts chemistry into motion. Every breath, every smile, every glance is a small expenditure of energy that once burned in a star. There is a quiet comfort in realizing that energy never dies. When a candle goes out, its warmth is not lost, it drifts into the air. When a life ends, the energy that sustained it disperses into new forms: soil, air, memory, story. Transformation replaces loss. The current never stops moving. It simply finds new paths. In that endless continuity, there is reassurance. Nothing is wasted. Nothing truly disappears. If the universe is indeed moving towards stillness, then that stillness may not be tragedy, but peace. A long settling after eons of creation. Until then, the poetry of energy is found in every glowing star, every heartbeat, every rustle of leaves. Life itself is a temporary borrowing of brightness, a brief, exquisite chance to feel warmth, to move, to love, to witness light. Existence is the act of spending energy beautifully while the current still flows. Throughout history, energy has shaped both the physical and the human world. Fire gave warmth and vision. Agriculture stored sunlight as grain. Coal and oil released the energy of ancient forests, fueling industry but leaving shadows behind. Electricity carried that same fire into the modern age, powering cities and connecting minds. Renewables now remind us to return to balance, to live within nature's steady income instead of its savings. In each era, energy has not only powered machines, but defined meaning. It built civilizations, but also language, ritual, and art. From sparks in a forge to sparks of inspiration, its story and ours are the same. Inside the body, the same economy repeats itself on smaller scales. Food becomes motion, thought becomes fatigue, sleep becomes repair. The heart tallies the accounts with every beat. The brain spends lavishly to think and dream. Muscles demand payment in breath and fuel. To be alive is to keep the books of energy in balance. Across species, evolution follows the same accounting. Organisms survive by managing their budgets well. Dinosaurs grazing under ancient suns, hummingbirds hovering on the edge of exhaustion, humans standing upright to free their hands, all are strategies in the art of efficient energy use. The cosmos itself obeys the same laws. Stars are nuclear banks. Galaxies are grand markets of exchange. Supernovae are acts of exuberant generosity, scattering the ingredients of new worlds. Black holes are vaults that hoard, yet even they repay the universe over time through radiation. And through it all, entropy is the patient auditor, ensuring that every act of order carries a cost. No motion, no life, no thought comes free. Every pulse of creation is balanced by dispersal. Every flame leaves behind a trace of ash and heat that returns to the whole. And yet, this vast, impartial system is not cold. It is alive with motion, rich with transformation. You are part of it simply by being here, by breathing, by perceiving, by spending energy in awareness. The electricity that carries these words to you is part of the same lineage, descended from starlight that has traveled across space and time to find form as thought. Just by listening, you have joined the circuit. Energy has passed from fusion to photon to planet to neuron, and now, briefly, into meaning. True wealth, when all illusions are stripped away, is not money or possession, but energy. The sunlight that grows food, the calories that sustain life, the currents that carry communication. Money measures it, but cannot replace it. Energy is the original currency of reality, the only one that cannot be forged or imagined into existence. It is both literal and symbolic, powering machines while also describing joy, love, and courage. In this sense, energy bridges the measurable and the mysterious. It lives in both science and metaphor. It can be calculated precisely and still inspire wonder. It gives humanity the words to describe what cannot be touched, the brightness of hope, the gravity of connection, the warmth of kindness. It reminds us that physics and poetry are not opposites, but reflections of the same order, the attempt to describe movement, change, and belonging. Now, as this story comes to rest, imagine the flow continuing beyond these words. Energy surrounds you, passes through you, and will continue long after you are gone. The same current that fuels the stars fuels your pulse. The same entropy that governs galaxies governs the rhythm of your days. You are a temporary steward of light, a brief expression of a universal exchange. Nothing is wasted, nothing is lost. Everything transforms. The warmth you feel, the thoughts you carry, the stillness you enter, all are part of that eternal circulation. Energy has carried existence from the first fire to the last photon, from the glow of creation to the whisper of equilibrium. It has been called by many names: light, heat, motion, life. But beneath them all, it has always been one thing, the thread that connects everything to everything else. To recognize this is to see the universe as it truly is, balanced, restless, and endlessly alive. And as the current flows quietly on, the story of energy continues unbroken, luminous, and still expanding into the vastness beyond.